ensuring the alignment from pre-K to 5 and ensuring that your kids are ready to move on to middle school and have the math and the knowledge to go on to their next life. You're at the beginning stages of it. I love kindergarten. They're still fascinated. I shouldn't say that. Kids here are fascinated with school the whole way. But they're still delightful and really questioning and enjoying everything we do. So my one little caveat, some of you have heard this before, I'm going to make it shorter. Math is something that absolutely everybody can learn. There is no such thing as a math brain and a non-math brain. That is a myth. That is more of a Western problem, to be honest, than an Eastern. But we need to make sure we don't give those accidental messages to our kids because it starts really young. It starts in their cartoons. It starts all over the place. We need to make sure that our message is positive, that math is something to be enjoyed and be curious about, and it's a creative process. If you don't have those feelings, it's time for you to open your mind and accept that, because our kids read us really, really well, and they can tell. I'm pretty sure kindergarten math doesn't scare you, but please keep that open mind as they hit 3rd grade and you're seeing stuff that looks different to you, and 5th grade when it looks different. Hopefully by 5th grade you're also going to see, really, wow, what they were doing in kindergarten, I can see roots of what they're doing all the way back. We have a very aligned curriculum. We teach it for a reason. It's based on research. And the research says we've got to start with concrete. That means we have to feel it, we have to manipulate it. And that is the heart of kindergarten. This session today is a little bit different if you've come to any of my other ones. We're going to go through the whole year. It's kindergarten. I really don't need to go unit by unit with it at KG. So I want you to be aware that this is on paper because I'm giving it to you as an adult. Your kids may see some of this on paper, but most of it they're going to be doing it. So the stories are going to be told to them, they're going to act them out, they're going to build them. Yes, they're on paper for you, and you'll see some of this. We do, by the end of the year, want that transfer over to some paper, but we need to have them do building it. They do move to pictures. I've seen their pictures. Sometimes they're beautiful. Sometimes it's a good thing they can explain it to me. That is appropriate at kindergarten. We want to know that they're making their own knowledge and that they're understanding what they're doing. So I am going to give you their curriculum through May. Please do not go home and try to teach it to them tonight. I'm serious. You may think it looks easy because it is for you because you're not 5 or 6. But for them, they need the time. In the young grades, there are actual documents that show me where they should be at 5 years, 4 months. 5 years, 5 months. Their brains are growing that fast and that much. So although it may look easy, some of your kids may be struggling if they're at 5 years, 1 month, and the child next to them is 6 years. There really is that difference in their brains. And your kindergarten teachers know it, and they applaud and they celebrate what each and every child is doing, because they may not get it, but we know they may not get it yet. They will. Now, those differences by 1st grade really do start coming together. So by 1st grade, we don't see those big discrepancies by age. By 2nd grade, it's almost gone. So please don't compare your kids to each other, because it really could be their age, and it may not be their age, but maybe they're not ready today. They will get there, especially with your smiles and your joy of math, okay? So, I'm going to give you some of this information. Well, first of all, if you ever need to contact me, this is my email. It's the typical standard email for ASD. ASD Parent Math Resources is a website that I put up for parents where you can get copies of things. This is being taped. This will be put up onto the website. This packet will be put up on the website. I'll even do all the work neatly and put it up on the website if you need it. We try to put up the parent strategy letters. The parent strategy letters come home from each unit. They usually talk about the vocabulary and exactly what's being taught the next 3 to 6 weeks. Those strategy letters are really important. They give you an aid as to what to talk to your child about. In kindergarten, I think well, probably still depends on your children, but how many times do you say, how was school today? Fine. And you actually want to know more. Ask them specifically, what did you do in math today? Is a step better. But if you know a word, oh, did you do something with 2D shapes today? You've given them an idea of what they should be talking about, because sometimes they really don't know what you want. Sometimes they may just be tired and not want to answer you. I do know that by the end of the day, at 5 and 6 years old, they've done a lot of work. But those letters are there to support you and help you know what's going on and give you that opportunity to chat with your child. I'm also including in one place, well, that's there. Here's a quick, can you even see that in the back? Here's. Okay, can I really turn off the light? No, we got this one off. Can you play with point off? It's just so, well, you got it in front of you also. These, I would say, are some math words that we use with your kids. We do not test these types of vocabulary, but you probably want to know them. We're going to talk about the types of counting. Compose and decompose. They are the excellent right terms, but they really mean to compose means to put something together, and decompose means to take it apart. The teachers will use that language, but while they're using that language, they're going to be explaining it with other words, they're going to be demonstrating it, so we're not trying to do a gotcha, do they know the vocabulary? But it is proper mathematic terms. And we know that 5-year-olds can learn the term Tyrannosaurus Rex because they have an interest. We have 5-year-olds who we talk about talking like a mathematician. You know, sit up straight, be a mathematician, and they love it. So we give them the opportunity to use that vocabulary. Number bonds we will talk about later. What I wanted to show you here was a number bond is about part, whole. So if this number was 5, this could be 2 and a 3, could be 4 and a 1, could be anything. What we want to show you is it doesn't matter which direction they're facing. We see them probably mostly like this, but you can see them anyway. It is still that part, whole relationship. The 10 frame here, last year they were using a 5 frame. Older and wiser now, they've moved up to 10 frames. And we're going to talk about subitized and number sentences as we go along. The reason I put these on a separate page, these are the adult words. We're going to learn how we're using them and what they are as we move along. The very next page, I am not going to ask you to read right now. If you are interested in the vocabulary all in one place for the year, here it is. It depends. Depends on the unit what's going on, but you can see the language that's being used and kind of the language that if you were to support us with that, it would help your child that they're hearing the same thing. You know, minusing, there's really no such word as minusing. We're going to accept that. We would use takeaway because that's physically what they're doing. The next page also is for you if you ever want to be working with your child where you're asking questions. It's just not a worksheet, it's a template of our 10 frames. And you'll see that it goes above, there's 2 10 frames because by the end of the year we will be into the teen numbers. I'd like to get started. Those were just kind of informational. This is the work that your child has completed so far this year. It was about counting. I want to be real particular what counting is. One-to-one correspondence. This is 1, this is 2, 3, 4, 5. That's one-to-one correspondence. They know that the number is attached to a quantity. It's not 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That's rote counting. We do ask the kids to do that, but that's just knowing the order of the words. The one-to-one correspondence is the important part of counting, so that they know they touch. To begin with, the very first thing we ask them to do is, how many are there? They pick it up, they move it, and they say 1, 2, 3, 4, 5. That's the beginning stages. Honestly, they did that in pre-K. Some kids still need to do that, and that's fine. The next level of counting is in a row. They can go 1, 2, 3, 4, 5. That is actually a second step for a child. Then there's a little bit of debate whether they're over the next two, which one's harder. If we put them in a circle, can you imagine what the problem is going to be? So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you can see this is cognitively a step up for the kids. So we don't do circles until they're pretty good on the other. And this one in the circle, scattered is more difficult for them. So when there is no pattern or order to it, we're asking them to make order with it. The vast majority of kids will line them up, or they'll move them aside. That's great. They figured out a strategy to help them get through something that was harder. So in the first year, they were doing a lot of counting. They would count this up. So how many are there? Let's count.
2, 3, 4, 5, 6, 7, 8, 9.
Okay. Then we asked them, how many were there? We hope to get the answer 9. At the beginning of understanding, the child goes back and recounts them. They don't automatically know that the last number counted is the amount. With a lot of practice, they start seeing when they count it up again. So that question of when they've counted something, immediately say, and how many was that? Gives them that connection that the counting tells them the quantity. So they've been doing this, as I said, this unit was in September and October. The 1 more, 1 less, you have 3. If you add 1 more, how many do you have now? This is still considered a counting strategy. Of course, it will eventually add in or move on to being +1, but right now it is counting to them. I have 3 plus 1 is 4. I had 4. If I take away 1, 1 less, I should be saying 1 less, not take away. 1 less is 3. They were doing this up and down till 10. In speaking with the teachers yesterday and today, they said, please, this isn't solid yet. They've got the idea. I would not be asking them in the car, 1 more, 1 less. I want them to have the manipulatives in front of them so they can do it. They might be able to do it without the manipulatives, but I really want them to have that available to them. I'm using the red and yellow things. Chips, there's also the Unifix cubes on the table. It doesn't matter. Beans. I think kids like having a variety of things to use. These are nice because they're colored, but pinto beans versus black beans, pasta, anything can be used as a counter. So would you take a handful? I think probably it's easier for me to take this handful. Don't go too high, they're less than 10. Just take a handful of counters. Just put them on your paper, put them someplace. How many are there? What would be 1 more? You would add this to them. So what am I doing? This is exactly what you would do with your child when you drop down a bunch of forks because they're going to set the table. We're taking this, well, what would be, if somebody else is coming to dinner, what would we need? We would need 1 more. How many would that be? Johnny and Susie decided to eat over at somebody else's. No, just take 1, excuse me. Johnny's decided to eat at somebody else's. What would be 1 less? The more we can move these discussions into real life, they're just going to start putting math as part of their daily routine. So we would do this real life with them with the counters. I've given you a problem here on the paper, which is a little artificial, but it's just so you can see it. So we can count the objects, 1, 2, 3, 4, 5, 6. Write the number, 6. 1 less, put an X on an object. Oh, I don't want to mark that one out. I'll mark that one out. Now count the objects that are left, is 5. And 1 less is probably harder than one more. So there isn't kind of an order of learning it. Right, so that's what they did in September and October. Right now, your kids are in a shapes unit or a geometry unit. It's the 2D and 3D. I wanted to mention it. I've given you the lists of the circle, the cone on that front page. So this is a great observation time. I think a lot of times we have plenty of time with our kids in the car. Look around you. What shapes can you see? You can call it I Spy. You can take turns. So that's the recognition and being able to describe the shapes is what they're doing this month. Within that unit also, they're using comparative words. Taller than, shorter than. So I'm going to read this to you, but I would like you to do your own picture. And I suggest you don't draw a palm tree like I did because of the question about the branch. So it says, draw a house. Draw my sister, shorter than the house. Draw a tree, taller than the house. Draw a branch, shorter than the house. Draw a snake, longer than the branch. Would you please go ahead and do that? Yeah, I thought I was being clever drawing a palm tree. I got myself into trouble. Could you now turn to a partner and tell them something about your picture? In other words, we're now asking the kids to use the same language back. And talk to them about the comparison, not about how beautiful your picture is. So there's a very big, I'm using that term cognitive, the difficulty level. Following directions is easier than turning around and describing it back. So we always want to make sure that's how we can oomph the level of it. So they can describe it. And the way to push a child, if they get this, is can they make a comparison that wasn't asked for? Can they start comparing the snake to the house or something? But just always asking, taller, I'm gonna get the words right, shorter, taller, longer, and then they start getting the pattern of that comparison. And it's confusing, because if I ask it one way, the snake is shorter than the branch is longer than the snake. We don't try to trick them that way in kindergarten. That's an awareness thing. That's where I might start pushing a child who's got this down. Do they understand that reverse relationship? So that's how we can start increasing the complexity of what seems like a fairly simple task. What you may be noticing, a lot of math in pre-K and K is about language. And it's very important. It is foundational and they need it. So in this one, your kids will be playing. When we ask them heavier and lighter, they have a scale in front of them. We don't have plenty of scales for you guys to play with, but we do. We start asking them, Could somebody tell me, if you can't see, these are clothespins, this is a soccer ball. What do you think of it? Do this. What could you tell me about this scale? Don't tell me, tell your partner, tell somebody at the table. Quit asking me, please. Okay, I do want to take it back. That was actually not on purpose. I heard somebody saying they were equal. Equal, the word equal is a very abstract term. We might use it a little bit, but the language we're really using is it's the same as. The clothespins have the same weight as the ball. It has the same as. The equal sign, honestly, is just a sign, and it takes a long time. Now, we're going to use it, but we're going to make sure that they hear it. Same as, same quantity, same value. Because we know later on to kids, as they get older, the equal sign means get an answer. What? That's not what it means. That's a misconception that we want to make sure doesn't happen. Yes?
What's an easy way to help them remember which one is an add between the plus and the minus signs? Which one's an add and which one's a subtract? My son always got confused between these two, and he'd say,
So is he writing down 5 minus 2 equals
like
7?
if I say 5 plus 1 or 2 minus 1, and then he says, he tries to figure out which one is the add and which one is the subtract.
Right, because you've taken it to a very abstract level.
Okay.
That's what we're going to talk about. We should be talking about four ducks on a pond and 2 more come. They're not ready for that plus and minus sign yet if they don't know. We need to build that foundational level of, and in kindergarten, there are other stories for subtraction, but we are only dealing with takeaway, not comparisons. So it's adding on or more. So I get stuck using the term adding on. So more ducks come. So joining in, those are all those words that are the easier to access, and those are the type of stories we tell in
So it
kindergarten.
should be some more visual for them when we want them to make a calculation, let's say. Because
Okay,
that
can
is more visual, right?
We're going to talk about it right there.
All right.
So I just want to get through.
Sorry.
They are definitely comparing right now, so they're comparing weights, they're going to compare volume of water. They are then, at the end of this unit, going to compare numbers. So 5 is more than 2. We are not going to try to say then 2 is less than 5 with this picture. So that language in this unit, it's all about that language of more than and less than. Would you build this last one? Would you build 4 and 2 and then 4 and 3? Yep, build it. Your kids would be building all of this. Again, I gotta keep rolling here. So which one is more than the other one? And how do you know? So I want to look around. I'm going to quickly see. There are people that put these together. And they're taller than, so that one is bigger. That's one solution. I was very pleased that people were comfortable, and sometimes kids are and they're not, that the vertical versus horizontal alignment, it's a big deal that we're talking about the quantity, not how the picture or the things are landing on the table. So can we do this? Yes, if you need to. You can count them up individually and get the number. There was a child who said, well, those two are equal. I'm just going to look at this one and it has more. That's a pretty high level comparison. So this is why we ask your kids, oh, you did it that way. Is there another way you could improve it to me? If a lot of kids, the one way is great. So I'm talking about those children who saw this easily. I'm going to ask them, can you do it another way? Okay, I would like to get to February. So we are in a time capsule. These dates are very loose. I just put them by month. I think this one actually begins, doesn't matter, a little bit in January. The crux of first grade, kindergarten, is this joining and separating unit. This is at the time where we actually start putting together and taking away formally. They're talking about it all the time. They're doing it all the time. Now we're doing it in math class as math. And you'll see, we're starting with a story with a real life thing. I'm talking about ducks. I'm talking about ducks facing one way or another. I would ask the kids to describe the ducks. So, look at the ducks and make 2 different number bonds. I don't care for the wording of this. So a number bond at this point, they know how many are there total. So I've got my manipulatives out. I can count 1 for 1. I have 1, 2, 3, 4, 5, 6. Okay, I have 6 total. How are they different? What are the 2 groups? What makes them 2 groups? Yeah, that they're facing to the right. So I can see that. Whether I do it with 2 different colors or not isn't important, but some kids will absolutely want that. Fine, that's what makes it work for you. So I know that there are 4 and 2. This really isn't a different number bond, it's just that we wanted them seeing the part whole. And this could be, does the order of the add-ins make any difference? No, it can be 4 and 2, or it can be 2 and 4. And they're starting to see that at a young age. Those got the same answer. So we're moving on. They're doing lots and lots of this practice. They're telling their own stories. They're making them up. In kindergarten, I'm still expecting that they're probably going to draw ducks or something for them that's a duck. As we move up the way, we expect them to move to mathematical pictures, which would be like circles and X's. In kindergarten, a lot of kids, it needs to be that concrete representation. So the next one is, there are 6 flowers in the garden. Some are red and some are yellow. This problem, remember, we're moving quickly through time, just jumped way up. Because now the kids are getting to decide how many, and there are multiple answers. And that's where that understanding of how to decompose a number. I can take 6 apart many different ways. I did pick red and yellow on purpose. Well, I could have, I'm just grabbing, I want it different than up there though. So I can build it. Some are red, some are yellow, and I have a total of 6. What would I do with this? 6 is 3 and 3. Lots of kids would take this and do that. That's probably a more beginner step. And I don't mean beginner as a bad thing, but some kids are going to want them together, and some are still going to be able to see it without putting them together. That's just the development as we go. And then we would write the number bond 6 and 3 and 3. Would you please solve this problem a different way than 3 red and 3 yellow? Yes. So I could do 5 and 1. I could do 1 and 5. So it's that fluency, this is where they start building their fluency of understanding the combinations. On this particular one, it's to 6. That is the flexibility of being able to break a number apart and put it back together to meet the needs of particular problem. This one looks it's very similar, but what we want to start practicing, can't see it up there, is that this can also be the equal sign here. It's the same problem. So we have 7. I have 4 apples. I have 3, I think those are oranges? I'm sorry, because it's 5. I could try to claim that I'm trying to see if you're paying attention, and I did that on purpose. I didn't. So it is 5 and 3, which equals 8. So 8 equals 5 plus 3. This is again back to that same as, and I'm sorry, I should be saying 8 is the same as 5 and 3, but that understanding that it doesn't matter how the problem is written, that it's representing the same thing, because we get in a really bad habit of only showing the second one. And then when kids see other problems, it throws them. So we need to make sure they keep seeing the variety of ways of writing an equation. We call this a number sentence. Kids are shown this. They're encouraged to write it if they want, but it is not an assessed standard. But we always show them a picture. Honestly, we start with the building. I don't have the right colors, but that doesn't matter. And then the picture, and then this is the abstract level. And again, we show it to them, we demonstrate it. They're welcome to copy it, but we don't ask them, we don't assess them on it. That comes in first grade. But they're wonderful little human beings, and they love to see what's going on. They'll attempt it, and that's what we really encourage. Attempt it, but we're not going to say pass or fail on something like that. Okay, so we move on to subtraction in this unit. We have 1, 2, 3, 4, 5, 6, 7 flowers. Yes, there were 7 flowers. I picked 3 of them. Keep these all red just because that's how my brain works. 3, 4, 5, 6. I picked 3 of them. That's a takeaway problem. I can show it with manipulatives. I can show it on my picture. I'm moving very quickly here. This is a 2-week lesson, not a 2-minute problem, but you're seeing how we're building. So we have 7. There were 4 left, 3 picked. I would draw it, and I have 7 minus 3 equals 4. From here to here is pretty easy for the kids. We always offer them everything. There will always be manipulatives for them to do it and physically move the 3. But they can understand the crossing out. This starts, we've gone into a much higher level by taking it abstract. So this is going to be the practice in the winter of what they're doing. I gave you 3 more problems, but I'm looking at the time. I think, would you like to practice them? Why don't I give you 30 seconds? Look at them. I'm looking for the one. Okay, so there we go. Again, if you're practicing or supporting your child at home with this, make sure there's some sort of counters that they can use. These are the type pictures and these are the type representations we would be expecting. If your child says, I get it, I'm going to ask you to split the page. And I'm going to apologize, one number got pushed off onto the other page. this number bond before. The extension for the children who get it, I give them the picture and I say, what's the story? So it's not only that we take the real life, we call it the context, and we decontextualize it, that's putting it into the math. Can they take the math or the arithmetic and put it back into a context? That's a way that we can extend for a child. Can they look at this and make a story for it that explains what they're doing or explains the picture? That's something also that you could do. I don't need to hark back to being in the car, but that's a lot of time when we have good space that we can be making it. That if they're making the story, they don't necessarily need the things in front of them. And now I'm going to do a caveat. They do have things in front of them. Fingers are wonderful. Please do not discourage them. These are as much as a manipulative as any chip or anything you're using. Fingers are good. They're trying to make sense of their world. So if you're sitting in the car and they do this and you say, oh, tell me a story about it, if they need to look at this and they want to do 5 and 3, that's great. So they're always walking around with at least a first level manipulative with them. I was embarrassed that I had not made the connection. Our numbers, our individual numbers are called digits. So are our fingers. And that is, what do you call that, in the language world, that is on purpose. They were definitely connected. I had never made that association. So these are our friends. We practice enough with these numbers that the kids should be moving away from it, but when they need them, they use them in pairs. Okay, that's a really big unit. It's unit 4. It goes up to the spring. By April, we're going to go into teen numbers and understanding that the teen numbers are built with a 10 and some others. And we talk about that. Now they've been counting that high, but now what does that number look like and represent when they've gotten it written down? So we build, another reason why we gave you the 10 frames, is that they are going to be building these numbers and understanding where these parts come from. So, I brought up digits at the right time. This says, color the number of fingernails and beads to match the number bond. Show by coloring 10 ones above and extra ones below. Fill in the number bond. And I'm sorry, one little space on my printing. Here's the picture of the hands. So, would you please color the fingernails to match the number bond? So our 10 digits, again, really help us with that understanding of our base 10 numeral system. Sorry, so we're supposed to color 5 fingers, is that what that means? No, I think it said 12. Oh, 12. To be honest, I cut and pasted this picture. I think they're red and white just to show that they're still helping the kids see 5 and 5. So that's just representing the 2 different hands.
Okay, and so then the circles are the beads that we're supposed to be coloring? Is that right?
I think that, I see this as the beads, or the thing underneath are just representing 5 and 5.
I see.
Okay, just, no, so color the fingernails. So what to me, you're going to color 10, the 10 at the top, and 2 more.
Okay.
Yeah.
But this is quite advanced.
They're ready by April. It's going to be very hands-on, they can understand, and we do it a lot. And this is where the 10 frame helps.
I guess there's a lot of questions that I need to right?
There's a lot of questions.
They were all given class, and the teacher.
No, remember, I had to find something that I could do with you as adults.
Okay, so.
They're gonna have 10 frames in front of them, and now that I've seen the discussion on this, I particularly wouldn't use this question. No, they're going to be building it. I needed something I could put on paper for you. They're going to have 10 frames in front of them. Yeah. They're going to have cards. They're going to flip over a card that says 17. I'm going to say, what does that mean? And hopefully they're going to do a 10 frame with a full 10 and then 7 more. It's really that idea of 10 and some more. And the teens are hard. In the English language, we choose to make it even harder because we use 2 different systems of, we go from 12 that doesn't really linguistically, it's not 10 and 2. I mean, I think it's Chinese, it's 10 and 1, and 10 and 2, and 10 and 3, it's Spanish.
It's not in Greek, it's the same language.
Yeah, but then we switch halfway through, then all of a sudden it's 13. It's like, really, we couldn't have at least done 1 teen, 2 teen, but it doesn't matter, we don't get to change the language. And they survive. I promise that they will know their teens. They may need more time. The expectation at first grade is to be add and subtracting word problems up to 10, fluent in their numeracies, their facts up to 5. So we're not asking them to do a lot, we're just asking them to understand what that problem, that number is. And you're right, it's a big concept. Saying 13 is easy. Knowing where 13 falls between 12 and 14 is easy. Understanding what it is takes building. And that's where that 10 frame really helps. So they will be building and building and building using these. And they get very good at knowing we put these together in 10s. And whenever I have the people put them away, I want them put in 10 so we can grab a 10 and some more. And this is where I had you promise you're not going to go home and start talking to them about the teen numbers today, thinking you're helping them get a head start. They're too little, they're too young. Give them the time to build up to it. And next spring, we'd love your support. Okay, I want to get through the year. We got to spring. We're going to do a lot with 10 and some more. And then they are going to revisit that idea of and one more. Kindergartners are expected to be able to count to 100 by 1s and 10s, but they're also expected to be able to start at any number. So they start at 23, 24, 25. They don't have to go all the way back to 1. This is very similar to the ABCs. Lots of kids can sing the song, they don't even know where the breaks are in it. We want to make sure that they know where things stop and start. So we do, by the end of the year, start doing the 1 more, 1 less of the bigger numbers. But it's the counting, not the adding and subtracting. So let me take a look. So we've got these pictures. This was originally, how many? 10, 20, 21, 22, 23, 24, 25, 26. We put 1 more on, and we have 27. Go back. We're not doing this with a picture. We've got the cubes, or we've got the manipulatives in front of them, and I won't use the word add. They're putting 1 more on, and they're taking 1 off. 1 less.
And at this stage, they recount, do they add 1 more, or?
That's developmental. What we would be, I would be hoping to see is they can hold the 26 in their head and they can do 1 more. If they have to count, they have to count. What I want to make sure is if Sally is going from 26, 1 more is 27, and I'm sitting there and I'm recounting, I'm going to want those 2 talking. I might be able to just go on 1 more, but I think I'm being asked to recount. So you want them to be exposed to those different strategies of getting the answer, because I may know how to do that. I just thought you told me to recount. So there's a difference of needing to recount versus thinking that's what's expected of them. So we want those kids talking, and that's why we always ask the kids, how did you do that? Or why did you do that? Oh, I knew there were 26, I can just go 1 more. That may help me completely go, oh, I can do that. Or I can go, no, that doesn't make any sense to me. I'm going to start and count. This is why we keep having kids explain and why we lead the kids talking with each other so they hear it from each other and hear these different strategies. To round out the year, I already just mentioned the counting up. It is by 1s and by 10s. So they will be having 2, 4, 6, 8, 10. They'll go 10, 20, 30, and they will be building them, and they'll be going up and down, and with ones, being able to start any place and go up and down. They're not getting this graphic, again, this is for you.
Do you also use like 10, like grade 10 and like solid 100
Yeah.
blocks?
They don't have them down there, because they don't come apart. They would have to count, so we
So
use,
that they know this is 10.
yeah. She's talking about place value blocks that come nicely built already. They're probably not used, I mean, a teacher may have them, there's nothing wrong with them, but they would probably use these, and they would have these built as tens. I mean, I would have the kids build them, because if I only have 7, that's the perfect, well, how many more do you need? 3. So we use everything that we're doing, we're bringing back to their understanding of the numbers. The last unit, which will be May, so we're up to the end of school, is about shapes again, but composing and decomposing. It's a fun unit. It's again, how do you see a house? If we had, I'm sorry, I'm picturing a very traditional American picture in my head. If I have a house, what is it made of? It's made of a square and a triangle. We didn't do that in the previous unit. In the previous unit that they're in now, they were just recognizing and comparing 2D to 3D. So they end the year with shapes being put together, being composed, and shapes being decomposed and taken apart. It's a lot. All the kids are perfectly capable. We're going to get them there. As I said, they're all going to arrive at the same point eventually, but we're going to work with the kids and move with them as they need to move.
So the shapes is what you're writing here in the vocabulary. This is what they're learning.
That's
in Unit 2.
right now, they're in Unit 2.
This is what
This-
the shapes they're learning in the
Yes,
vocabulary.
yes, so they do list them, cone, sphere, I can't list them off the top of my head, but, I have 2 minutes for questions. Anything about this? Yes?
Yes, this last part, sorry. The last one, what is this shape about?
It's about putting 2 shapes together. This is a triangle and a
So
square.
basically 2 triangles form a square, this one, the one and two?
Oh,
And-
no, they were just showing that you can make a rectangle. You don't have to have only squares to build a rectangle. You can do it with triangles. Those are just examples that showed the different pieces. So I might ask you, what is this rectangle made of? It's made of 2 squares and 2 triangles.
Okay, I'm just counting the number of shapes and not like,
They were probably, by putting numbers in it, you can say, oh, number 1 is a triangle, number 4 is a triangle. It's just helping them talk about it. It's not about, it's a label to help us talk about it. Yeah.
So this is really advanced language, like square. It's a flat figure enclosed by 4 straight sides. I'm sure that they weren't learning it like that.
No, they're not. What we're trying to get at though is it's a 2D and 3D shape. So flat means 2D.
Okay.
And the kids they understand flat, they don't understand 2-dimensional.
Okay. So we keep it
And
flat.
the definition of a square is the 4 equal sides. You notice it didn't mention angles, it didn't go to the level that they will need eventually. That as a kindergartner, we want 4 equal sides. That differentiates it from other rectangles. Because of course it is a rectangle. So I did give you the vocabulary that we give to the teachers. I read through it. I'm not going to use specifically using direct comparison. So some of this is to help you understand what we're talking about. But the vocabulary words themselves are what we're using.
So what is a 3D shape? Because they wouldn't like that. Here it says a solid shape. So how do we show them the solid shape?
They have them. They have all these manipulatives. They have a cylinder and they have a circle.
So basically,
This is 3D,
yeah, because it has all around.
right? It's not flat. This is
Because
flat.
it's not flat.
Yeah.
Okay.
That's the language they're going to
Okay.
use.
Okay.
And they have all those blocks. I hope you have blocks at home. So I am going to end on problem solving. Problem solving is the reason we learn math. Problem solving is what engineers do, is what our architects do, is what our scientists do, and it's what children do all the time. The best thing your kids could be doing for practice of problem solving is building things. Those blocks, cans of soup, boxes of cereal. If they build something and you say, can you make it taller? Can you build it with fewer pieces? Can you build it with more pieces? Can you build it so it will hold something? So problem solving is about that trial and error and getting them to design something and move on. In kindergarten, we will get to numbers as well, but really the research shows that the psychiatrists and things have told us that in the pre-K and K years, and it's especially pre-K, we do not do problem solving with numbers in pre-K. We build. In kindergarten, they're still building and we do them with numbers. The problem that we had, I'm not going to remember which one. I have 6 flowers, what colors could they be? That's problem solving, because they're having lots of options and they can attack the problem in different ways and come up with multiple answers. So that's what we're doing. But at home, keep having them challenged by trying something and then improving on it or changing it. And I'm going to go card games, anything that involves counting, anything that involves real life. If you shop with your kids, have them go get 14 of something. Have them compare something. And they're doing weights. Now, I'm not saying they're not going to be able to weigh something and tell you it's 14, help me with we wouldn't have 14 kilos, 2 kilos more than the other. But they can tell whether it's heavier or lighter in that language. Yes?
So it's wrong to do limits? Because sometimes they put on a board like 3 plus 1 equal, so she used her fingers. Is that right?
Yeah, that's fine. We call those naked numbers. We really want to make sure that they understand that they go with something in life.
I know, so she used her fingers to
Yeah.
count 1, then like take away, she do 4 and take 2.
Yeah.
Like this.
And by the end of kindergarten, they should know those facts up to 5. And so, yeah, you're going to get to that point.
Yeah. So what's right to use take away or less than or minus?
I'm going to get real.
Because you mentioned this.
Right, it's not, I'm not going to test a child on it. Takeaway is a subtraction problem. 1 less can be accounting, because I'm going up and then I'm coming back
So
down
on
the
this
numbers.
stage, 1 less is better for their.
You know what, they're going to hear it both ways and they're going to make the connection that they are related. But if a child wasn't understanding it, if I said it one way, I would switch to the other way. If it makes sense to your story. So, did you have a?
Yeah, I was just wondering, are the kids going to be challenged with larger numbers if they're in, like if, adding like double digits and going up like using number sets, I guess, that are bigger than the 1 through 10, 1 through 5,
Well,
if they're kind of there?
The expectation is through 20. They will be working with those numbers by the end of the year. If a child understands up to 20, they understand it. Making it 21 isn't encouraging it. No, we are not going to teach above the standards at that grade level. We feel secure that this is the best way to teach them. Where I'm going to extend them is having a more open problem. What are the different ways you could create 19? That's a much larger problem than 17 plus 2. So I'm going to extend them that way, not just bigger numbers.
Encouraging creativity.
Yeah, exactly. Can they write the story that matches that? Because that's a very interesting twist. You think it's automatic and it's not. It becomes automatic because we ask them to do it. Now, at some point, we've gone as deep as we can with adding, then I might ask them to do some puzzles. There are lots of, I'm pushing this with kindergartners, but there's these puzzles called Ken-Kens, and you have to put the numbers 1, 2, and 3. They're like Sudoku, I don't know, except that you have to add and subtract in them. So for a child who's doing the rote problems, I would go to puzzles. They've got puzzles, I don't know the name of them, where everything in this line adds up to the same number as everything in this line and everything in this line. So that's the way I would push them. It's really into logic. It's using those same skills, but that's the way to broaden their horizons.
But you stick to the foundations.
We've got to, and they're young. They need to repeat this, boy, they can master it by the end of November. If we don't keep coming back to it, and your teachers know this, they had it solid in November and it can just fall off late. So we come back to it. So even if they feel like we've mastered it now, you're going to be seeing it. They're going to cycle through. They do number talks to keep bringing it back. And they may have fallen back a little. That's appropriate. We know it. We practice it some more. So it can be 3 steps forward, 1 step back, 3 steps forward, but we do keep moving forward. So thank you for coming. There is a sheet on the back if you'd like to let me know how this was for you. I'm always available. This will be up on the website in a couple of days, probably Sunday, Monday of next week.